Okay, so 2, 3, 4, and 6, 2, 3, 4, 8, and 16 on the back. So in number 2, it's just a classic division problem to start. 24 divided by 32 gets reduced. Those are both divisible by 8. So we get 3 over 4 for that part. Now, right here we have x to the 3/2 divided by x to the 1/3 power. With common basis division, we subtract the exponents. A little bit tricky because they're fractions. Now, you can go out on the side and you can get a common denominator and do all that jazz if you want, or you guys have the benefit of a calculator. So 3/2 minus 1/3, and I'm going to do parentheses 3/2 minus parentheses 1/3. It's going to give me a decimal, which I obviously don't want. Hit your math button, your fraction option, and that'll turn that right into 7/6. So that's just going to become x to the 7/6. Whatever's left when you do that always goes on the numerator. So x to the 7/6. God bless you. And then here with the y's, the tricky part is 5 minus -2 is a double negative, which turns into 5 plus 2, which is y to the 7th, and that should match up with your final answer at the bottom. Okie doke? Okay, number 3, there's a couple ways to do it. With a negative exponent on an entire fraction, you could flip the entire fraction. So I might show this one in 2 ways. So if I want to address just the negative sign first, that I could just flip what's inside, because what's on the numerator is going to have to go to the denominator, and what's on the denominator has to go to the numerator when there's a negative exponent. I actually think that that's going to look a little bit nicer. You'll be able to tell me because I'm going to do both ways. And so I'm going to now just raise everything inside to the second power. Y to the second power? 5 to the second power is 25. X to the third to the second power, when you raise a power to power, you multiply. So that's going to be x to the 6th. And that should be the answer that we get. Perfect. Okay? The other option, which I don't like as well, is to distribute the negative exponent right out of the gate. So raise everything to the negative second power. So that would be 5 to the negative second power, x to the third to the negative second power. Again, that's a power to power. You multiply x to the negative 6, and then y to the negative second power. So kind of, it's not distributing, but I'm going to call it that, kind of distributing that negative exponent first. And then now we would have to address, and that has a negative exponent, so it needs to move to the bottom. 5 squared would be a 25. X to the negative 6 has a negative exponent, so that has to move to the bottom. And y to the negative second, which is already on the bottom, has a negative exponent, so it has to move to the top. So you end up with the same answer. I just think it's a little bit cleaner. It's never my favorite to distribute kind of a negative exponent to every term inside. I don't like to do that, because it just, to me, it's a lot yuckier. Number 4, I'm going to do the multiplication of common bases up top first, where then I would add the exponents. So 2/3 plus 5/3 would make that 7/3. Not touching the bottom yet. And then division of common bases, I would subtract, and I would get out my handy-dandy calculator because there's not common denominators again. So 7/3 minus 2/5. 7/3 minus parentheses 2/5. I get a crazy decimal, math, frac, and 29/15. Not a pretty fraction. X to the 29/15. Any follow-ups? Good, good. All right. 8 is like an identity, but with exponential properties. So determine the value of y that would make this an identity. So simplify the left. Anytime you see identity, simplify the left, simplify the right. So up top here, I'm going to simplify, and I have to add 2/3 plus 1/4. I'm just doing that on my calculator on the side here. Math, frac, and I get 11/12. On the denominator, when I raise a power to a power, I multiply, so that's x to the 1/12. Then I'm going to do my division of common bases, so I have to subtract my exponents. 11/12 minus 1/12 is 10/12. And 10/12 reduces to 5/6. So my left side is simplified. My right side is simplified. So when I bring that down, and now answering the question, what is the value of y? 5/6. Very good. So once you get them in the same format, you can answer the question. Okey-doke. So just an example of how that identity is thrown in there. And then 16 on the back was another proof. Simplify the left. So up top here, 2 times 3 is 6. X to the third times x to the seventh, or x to the second rather. Multiplying common bases means I add those exponents to get x to the fifth, all over x to the seventh. I'll work on the right-hand side later. I'm going to focus on just the left. And then division of my common bases means subtract. 5 minus 7 is -2. So it's 6x to the -2nd. And one more step, I would move that x to the -2nd down as x to the +2nd. I'm not moving the 6. The 6 does not have the negative exponent. That exponent is just on the x. So just the x moves down. And then on the right-hand side, are we good with the left? Any follow-up questions with the left side? On the right-hand side, again, I'm not going to distribute my negative. I'm going to flip it. So I'm going to make it 6 over x squared to the positive first power, which now that first power means nothing, and I'm pretty much done. It's just 6 over x squared. Check. Proven.